Happy morning, children. So today, usually know you children be very clear with the concept of reflection of light. So when it comes to concept of refraction of light, definitely everybody they'll have a confusion. So today we'll see the refraction of light in a full detailed way. Okay. So everyone knows light. Light, it is a form of energy and it travels in a straight line. It behaves like a wave, clear, and also like a particle. It's called photons, okay. And your light travels fastest in vacuum and slower in air and even slower in water or glass. So refraction is the bending of light when it travels from one medium to another of different optical density. Okay, the light wave changes your speed, which causes the direction to change. Clear? So, but why does light bend? Okay, so we'll see a simple example. So imagine a car going from a smooth road to a muddy patch. So one wheel they'll enter first and slows down, while the other still on the road, no, and it keeps moving fast. Now the car turns. That's your refraction. Clear? So, and I told you refraction is the bending of light when it travels from one medium to another of different optical density. And your optical density is not equal to your mass density, make it clear. Okay, and your optical density is how much a medium slows down light. That's your optical density. And more optically dense, light moves slower. Okay, glass is more optically dense than water, even though it may not be heavier. Okay, but it optically, your glass is optically dense than your water. Okay, so if add to water or glass, your speed will slow down, and the bending, no, it will be towards your normal. And water or glass towards your air, it speeds up and bends away from the normal. Okay, now look into the ray diagram and I'll tell you how it works. Okay, this is your refraction terminology, okay, with the diagram explanation. Okay, so the key terms we'll be using here is your incident ray, point of incidence, normal, angle of incidence, refracted ray, and angle of refraction. So we'll see one by one. Incident ray, that is your incoming light ray, and point of incidence where it hits the surface. Okay, and your normal is a line at 90 degree to the surface at the point of incidence, and your angle of incidence, angle between your incident ray and normal, and your refracted ray, the bent ray in second medium, and your angle of refraction, angle between refracted ray and your normal. Clear? Hope you'll understand. Move on to laws of refraction. That's your Snell's law. So what's the first law? The incident ray, refracted ray and your normal all lie on the same plane. Correct. And the second law is sin I by sin r is a constant. Okay, that's your mu. And that is your refractive index. So the ratio of the sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. So these are the two laws of refraction. So one is the incident ray, refracted ray and your normal, they all lie on the same plane. The second one, the ratio of the sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. Clear? Sin I by sin r is equal to, it's a constant. Okay. Your refractive index mu, no, it tells how much light slow down in a medium. If mu is equal to speed of light in vacuum by speed of light in medium. For example, mu for air is 1 and for water it is approximately 1.33 and for glass it is approximately 1.5. So higher your refraction index, more refraction. Okay. See, the very common example, no, the real world example always will be see bending pencil in water. Okay, so pencil appears bent because the light coming from the part inside water bends at the water air boundary. Okay, and in swimming pool appears shallow. Objects under water, no, they'll appear higher than they are due to the bending of light. Okay, so for example, if you have a heart here near the ground, no, it bends light from the sky towards your eye, so making it look like water. If you see it in desert and all, you can experience this. And convex and concave lens, no, they refract light to correct vision or focus images. These are the real world examples of refraction. Okay, so then move on to lateral displacement. So when light passes through a glass slab, it bends once on entry and again on exit, so resulting in the emergent ray being parallel but shifted from the original path. That shift, no, you call it as a lateral displacement. Okay, see, for example, the lens in your eyes, no, they refract light to form image on the retina, and magnifying glass, they use convex lens to enlarge. Optical fiber, they use total internal reflection. That is your next level top. Okay, and in microscope, telescope, they use a series of lenses for magnification. Okay, and rainbow caused by refraction and reflection in water droplets. Clear? So when light tries to move from denser to rarer medium at a large enough angle, instead of refracting, it bounces back. And that is your total internal reflection. Okay, so it is used in optical fibers, diamond sparkle, endoscopy, this and all, they'll be using this total internal reflections. Okay, so hope you'll understand better about refraction of light. Okay, if you have any doubts, please comment. Hope this video is very useful for you. Thank you.